Hi, and welcome to this video about derivatives of a function that is a piecewise function. We're given the piecewise function f of x equals minus 6x squared plus 7x for x negative, and 4x squared minus 2 for x greater than or equal to 0. And we need to do various things with this function. We need to fill out various boxes right here and conclude that f prime of 0 is certain thing. So let's see how we work with this problem. Now, to work with this problem, we need to remember the definition of the derivative. F prime at a number a is equal to two things that are equivalent. We have the limit as h goes to 0 of f of a plus h minus f of a over h. And that's the same as the limit as x goes to a, or x tends to a, of f of x minus f of a over x minus a. Because we have here, according to the definition of the derivative, to compute this, we need to compute the left-hand limit, and the limit as x approaches 0 from the left. Because we have that, the definition of the derivative that is particularly relevant to us is this one right here. So let's just write the definition of the derivative that we're going to use. Between the two definitions, we just go with this one. This is the one we will use. Okay, so that's the particular definition that we're interested in. Now, in our case, the f is the function right here, and the a we're interested in is a equals 0, because we want to conclude something about f prime of 0. We're thinking of a equal to 0. So f prime at 0 equals the limit as x approaches 0 of f of x minus f at 0 divided by x minus 0. And that's the limit as x tends to 0 of f of x minus, and f of 0 is given by 4 times 0 squared minus 2, because here is where we have the equal sign. So we do 4 times 0 squared minus 2, that's a negative 2. And then x minus 0 is x. So what we're doing is the limit of f of x plus 2 divided by x, and x approaches 0. Okay. Now, here we have the derivative of the function at 0. But our function is a piecewise function. We have certain formula for f for x negative, and certain formula for f for x positive or 0. Then we need to break this limit into two limits. One that is the left-hand limit, and then the right-hand limit. The left-hand limit is the limit as x approaches 0 from the left of f of x plus 2 divided by x. Now this is the limit of, and now x approaches 0 from the left, so x is negative. So f of x is minus 6x squared plus 7x. So we write minus 6x squared plus 7x. And then plus 2 divided by x. That's the left-hand limit. We choose the formula of f of x that corresponds to x negative, because x is approaching 0 from the left, meaning that x is negative in particular. So here we can write minus 6x squared plus 7x plus 2, and then divided by x. And the next box we need to fill is the value of the limit. Let's see. When we make x equal to 0, we find 2 on top divided by 0. And actually, the sign of minus 6x squared plus 7x plus 2 divided by x when x is negative. So this limit will actually be negative infinity. And because the left-hand limit is negative infinity, then here we can write negative infinity, or another option is to write undefined. When we get a limit that is negative infinity or positive infinity, the limit does not exist. Undefined. And we can write what the limit is exactly, or we can just say undefined. Now, on the other hand, the right-hand limit is the limit as x approaches 0 from the right of f of x plus 2 divided by x. And this time we goes with the formula for x squared minus 2. And then plus 2 divided by x. So the expression we're finding the limit of is 4x squared minus 2 plus 2 divided by x. And negative 2 plus 2 is 0. So we have the limit as x goes to 0 from the right of 4x squared divided by x. We can simplify the expression further by canceling out one of the powers of x. So we get 4 times x, and now we can substitute x equals 0 to find 0. So this limit, the right-hand limit, is 0. Now, because the left-hand limit and the right-hand limit are different, in particular the left-hand limit is negative infinity, we can say that f prime of 0 is undefined. In other words, our function is not differentiable at 0. Okay, that's it for this video. If you have questions, please write comments or contact me and I'll be happy to help you. Bye-bye.